Uh, this is V. Ramakrishna, professor in Department of AI and DS, here to present you about the file system implementation in operating systems. The main objective or the main aim of this session is to familiarize the students with the file system implementation in operating system, and the objectives are to understand the local file system and directory structures in operating system, and list out the allocation methods for space in secondary storage, and discuss the block allocation and free block allocation algorithms for the space retrieval as well as the space to be allocated to the files. And the learning outcomes will be, at the end of this session, the student will be able to understand how files and directories are organized and describe the different methods for the allocation of a free space on disks and their performance, and summarize the importance of the file systems in operation, efficiency and performance. And in this session we are going to discuss about the file system structure, file system implementation and directory implementation, allocation methods, free space management, efficiency and performance, and recovery and network file systems. These topics which we are going to discuss very briefly. And the file system structure will tells you about the secondary storage on which the file systems are being maintained. That is why the secondary storage devices are very efficiently managed with the help of these file systems for the users to provide a better understanding of how they retrieval as well as the storage of their data. And the file systems will provide the efficient and convenient access to the disk by allowing data to be stored, located and retrieved easily. And I/O control says the consists of device drivers and input handlers to transfer information between the main memory and the disk system, and the basic file system will issue the generic commands to the appropriate device drivers to read and write the physical blocks on the disk. And the file organization module knows about the file and their logical as well as the physical blocks where the files were exactly stored, and the logical file system will tells you about the metadata information like the file system structure of the files. And for any system, for any operating system, the layered file system will gives you a better approach to locate any particular file and the storage of any file. The application programs will undergo for the logical file system, and through the logical file system it goes to the file organization module, and in the file organization module it will tells you about the logical and physical disk or the blocks where the file was exactly stored. And the basic file system will depends upon the system calls. What the calls will give you is the efficient operations on the files, whether it is to be read or to be written to the disk. And I/O controller or I/O control will tells you about the interrupt handlers as well as the device drivers, and both will operate on the devices. And the file system layers, which consisting of the device drivers, manage the input-output devices at the I/O control layer, given the commands like read drive 1, cylinder 72, track 2, sector 10 into the memory location, and outputs the low-level hardware specific commands to hardware controller. And the basic file system given commands like retrieve block 1, 2, 3 and translates to device driver, and also manages memory buffers and the caches, and buffers will hold the data in the transit between the main memory to the devices, and the caches hold the frequently used data between the main memory and the secondary storage devices. And the file organization modules understand the file's logical addresses and physical blocks where exactly the files were stored, and it translates the logical block to the physical block numbers and manages the free space and the disk location by the file organization module. And the logical file system manages the meta information regarding the files and translates the file name into the file number, file handle, location by maintaining the file control blocks, and which can also be called as inodes in Unix. The file control blocks were normally called in Windows and in any other operating system, but in inodes are exclusively called in Unix operating environment. And the logical file system is also responsible for the directory management and the protection for the file system as well as the files. The layering useful for reducing the complexity and redundancy, but adds overhead and can decrease the performance. And the logical layers can be implemented by any coding method according to the operating system designer. And the most important thing is the file system and its operations, and we have the system calls at the application program interface level, but how do we implement their functions means on the disks and in-memory structures also of the in-memory structures of the disk as well as the secondary storage devices. The boot control block contains information needed by the system to boot the operating system from the particular volume where exactly the data has been stored, and needed if the volume contains the operating system. Usually the first block of the volume will be noted, and the volume control block will have the details like the total number of blocks and the number of free blocks and block size and free block pointers or the array of the pointers. And the directory structure organizes the files, names and inode numbers and the master file tables, and these are very much necessary to track any particular file in the directory and the directory structure. And the file system implementation in any operating system will be done using the file control block per file, and which contains many details about the file, typically the inode number and permissions, the size of the file and the dates on which it has been created, and the file permissions, file dates, file owners and groups under which it has been created, and access control limits, and as well as the file size, the file data blocks or the pointers to file data blocks, and everything will be written in the typical control block. And with the help of these file system implementation can be done through the logical file systems we can implement. And also in memory file system structures, we have to open any particular file, the file must be retrieved, or the file can be located by using the directory structure in the kernel memory, and also in the directory structure of the secondary storage, and basing on that the file control block will find out the particular file that is to be opened. And similarly, to read any particular file, and in the kernel memory, the per process open the file table which will have certain index, and that index will obtain the file where it has exactly located in the main memory, that is the system wide open the file table, and from the secondary storage that particular file will be obtained through the file control block, and the data blocks can be obtained. And the partitions and mounting is another concept for the secondary storage devices. A disk can be sliced into multiple partitions, or a volume can span multiple partitions on multiple disks, and partition containing no file system. That means any disk secondary storage that you have taken, when most it has been partitioned, it will not have any file system. and the mount operation will definitely gives you whether it will validate a particular file system on the device. And the partitions and mounting, these two are very much useful in creating the file systems on any particular secondary storage device. And next one is the virtual file systems, and this virtual file system consisting of three layers. One is the file system interface, and second one is the virtual file system, and third one is the local file systems, and the remote file systems on which these remote file systems are implemented. This is the schematic view of the virtual file systems. And next one is we are going to discuss about the directory implementation. The directory implementation is one of the selection of the directory allocation and directory management algorithms significantly affects the efficiency, performance and reliability of the file system. And one of the two methods with which the directories can be implemented through the linear list and the hash table. And second one is the allocation methods, which are very much used to allocate the files on the blocks. That is, one is the contiguous, second one is the linked, and the third one is the file allocation table. And next one is the free space management. The file system maintains this free space list to track the available blocks or the clusters. Using the bit vector or the bitmap, you can obtain this. And bit I, that is equal to 1, that is block I is free, is equal to 0 if block I is occupied. By means of this, a sequence of ones and zeros can be obtained from the secondary storage device, and the block number calculation can be done basing on the equation that has been given there. And next one is the free space management can be obtained by using this bit vector and the bitmap methods. And the second one is the linked free space list on the disk. That is, linked list cannot get contiguous space easily on any particular device, and no waste should be there in maintaining this linked free space list, and no need to traverse the entire list. Only the first block is to be required. The space or the address of the first block is only required. Next one is the efficiency and performance. The efficient use of disk space depends heavily on the disk allocation and the directory algorithms, and performance can be done on the basis of the keeping the data and the metadata closer, and buffer cache and synchronous free bind, free behind and read head accesses are very much useful to make the performance of the particular file system. And reads frequently the files or the data will slower than the writes in any particular operation. And next, the recovery. A recovery is done in any file system by using a failure in the particular file system, and even the file system is failed, the loss of data and inconsistency should not be a result. Therefore, a system failure does not result in any loss of data, and for that the consistency checking is one of the important methods through which you can do. And second one is the backup, and the restoring from the backup can also be done. And the network file systems are typically integrated with the overall directory structure and interface of the client system. And NFS is a good example of a widely used, well-implemented client-server network file system. And this network file systems consisting of the 4 protocols. The mount protocol establishes the initial logical connection between a server and the client. And the NFS protocol, a set of RPCs, the remote procedural calls, are building blocks used to implement the transparent remote file operations on the local file system by retrieving or mounting the data from the remote systems. And the path name translation parses a path name into separate directory entries, and the remote operations that will be performed on the remote systems under the network file systems only. And here there are 3 independent file systems with which it was mounted the directory 2 and directory 1 on the U. that was given here as an example. And if a shared file system is mounted over a user's home directories on all machines in a network, the user can log into any workstation and get their home environment, and this is one of the user's mobility property on the network file systems. And the design goals of network file systems was to operate in heterogeneous environment of different machines and operating systems and network architectures. This independence is achieved through the remote procedural call primitives built on a top of an external data representation XDR protocol between two implementation independent interfaces. And NFS protocol is useful for different services, a mount protocol and a protocol for remote file accesses. And self-assessment questions can be gone through this one particular one, that is how many methods described for the disk space allocation, that is 3 in this particular session. And the mount protocol establishes the logical connection between the server and the client. And these are the terminal questions, and the acknowledgements for this particular slides is the operating system concepts essentials, second edition, Abraham Selberchurch, Peter Bear Galvin and Greg Gagne, and are used to generate the slides for the university. I acknowledge the authors of the slides that helped in preparation of the slide content, and thank you for listening this particular session.